Good afternoon, everybody. Myself, I am Vaishali. I am going to deal with the paper, the course of the DBMS, which is DSA 5th sem paper, in which I am going to tell about the module objectives, the second unit, which include the ER model, in which I am going to discuss about the enhanced ER model, entity supertype, entity subtype, disjoint overlapping constraint, completeness constraint, and entity clustering. So the module outline would be what is entity supertype, about the entity subtype, what is a subtype discriminator, followed by the definitions that include disjoint and overlapping constraint, completeness constraint, and entity clustering. Let us now discuss about them in detail. Today's time, the complexity of the data is being increasing. As the data which we have to store has been increasing a lot, it has become very difficult to implement the relational data model or the traditional ER model in the data modeling techniques. It has become very difficult to implement the traditional ER model. So to reduce that complexity, to reduce or to come over that problem, we have made some improvements and enhancements in the existing ER model, which has been used to reduce the complexity of the applications and has become a better way of representation of the ER model. And it is called as the enhanced entity relationship diagram. The enhanced entity relation diagrams or advanced database diagrams are very similar to our regular ER diagrams, which are represented according to the requirement and which are being used to represent according to the user requirements and also being used to implement the complex databases very easily. It is a diagrammatical technique which has been used for displaying the subclasses, superclasses, specialization, generalization, aggregation, etc. Now let us discuss about the various features of the ER model. What are the various features of the ER model? So ER model, it creates a design which is more accurate for the database schemas. It is being used to design the schema which is very accurate, which gives us very accurate results. Also, it reflects the data properties and the constraints very precisely. It also helps us to declare the properties, what are the various properties used in the database very accurately, concisely, so that it can be understood by the user. So it also includes the concept of specialization and generalization. Here some special topics are also being included, which include the specialization and the generalization. It is also being used to represent the collection of objects that is the union of objects with different entity types. So different entity types are being grouped as a union and it is also being represented. These are the various features of the ER model. Now this is about the introduction about the enhanced ER model, which is also called an extended ER model or ER model, which is extended ER model or enhanced ER model or ER model. Now let us discuss about one by one in detail. So coming to the first definitions, what is an entity supertype and what is an entity subtype? So let us consider an example in which we are going to discuss about the aviation business. In the aviation business, there consists of different employees, which include pilots, accountants, mechanics, database managers, etc. We are going to consider an aviation business in which there will be different categories of employees, which include some will be pilots, some will be accountants, some will be mechanics, and some will be database managers. So now coming to the pilots. Pilots have certain special characteristics when compared with the other employees. When compared with the other employees, the pilots have their own specialized characteristics or some characteristics which are common for all the employees. Pilots share some characteristics with some similar characteristics with other employees, which include employee name, employee date of joining, etc. Employee name, employee date of joining will be same for the pilots, for accountants, for mechanics, and also for the database managers. Coming to other side, on the other hand, pilots have some specialized characteristics which are owned only by them. They do not have some characteristics, they will have certain characteristics which cannot be shared by the other employees, which include the special characteristics, which include flight hour restrictions, flight checks, periodic trainings, etc. These are the special characteristics which are being owned only by the pilots but not by the other employees. So all the employees' characteristics and their special qualifications are stored in the employee entity. So all the common characteristics all the characteristics that are common for all the employees, that is the common characteristics which include, as I already told, which include the employee name, their date of joining. These are certain common characteristics for pilots, accountants, mechanics, and data. Such common characteristics are being stored in one single entity, which is called as an employee entity. So followed by some specialized characteristics, some special pilot characteristics, which include employee license, his rating, his type of driving, etc., training, etc. These are the special characteristics of the employees, pilots, which are being stored specially. If they are placed in the employee table as these employee license, employee rating, etc., these are not the characteristics of the other employees, they will be left none. So to come over that problem, what do I do now is the pilot entity stores those attributes that are unique to the pilot. So we create a separate entity for a pilot, which is being used to store some special characteristics of that pilot. As we already told, employee medium type, employee speed of driving, etc. Such certain characteristics or such special characteristics are being stored in the pilot entity. So that in such way, all the similar characteristics are stored in one entity, which is called as a employee entity, which have some common characteristics for all the employees, and specialized characteristics of the pilot are being stored in one entity, which is called as a pilot entity. So based on this hierarchy, we can conclude that pilot is a subtype of employee. Pilot is a subtype of employee, and employee is the supertype of pilot. Employee is the supertype of pilot, because in the employee we have employee number, employee name, his date of join, etc. All these includes the information of the pilots also. All these includes the information of the pilots also. That is why I consider the employee as a supertype entity, and I define the hierarchy as in the down one, the second one as the subtype entity, which is called as the pilot entity. So entity supertype is an organized by specialization hierarchy. Entity supertype is organized by specialized hierarchy, where the higher level contains entity supertypes, that is the parent entity, and the lower level contains the entity subtypes, that is the child entity. So entity supertype, which is called as the parent entity, which is defined in the higher level, and below that we have the lower level, which is called as the entity subtype, that is the child entity. That is, the parent entity is here called as an employee supertype, and the child entity is called as the pilot. So employee supertype, here employee is a supertype. In our example, we consider employee as a supertype, and from this employee supertype I generate three subtypes. What are those three subtypes? One is pilot, second one is mechanic, and the third one is accountant. These are the three subtype entities which I am going to data. So the specialized hierarchy, it reflects a one-to-one relationship in between the employee and its subtype. So employee is a supertype, and its subtypes include three subtypes we have considered. What is the first one? One is pilot, one is mechanic, and the other one is accountant. So this, with the help of this specialized hierarchy, what can I provide? It provides us three properties. What are the first one? It provides attribute inheritance, followed by defining the special supertype, which is known as entity subtype. Here we define a special supertype entity, which is called as the subtype discriminator. Here we define a special supertype attribute, which is called as a subtype discriminator. It also defines us, it also helps us to define disjoint, overlapping, completeness, or partial. This is the diagram I am going to consider, in which I am going to consider the employee as a supertype entity, in which the employee number is being defined as a primary key, followed by other attributes which include common attributes for all the employees, that is employee last name, first name, his initial, his date of joining, the type of employee he is. This is the employee supertype, from which I am going to generate three subtypes, which include pilot, mechanic, accountant, which include pilot, mechanic, and accountant. These three are called as the subtype entities, and the first one is called as the supertype entity, in which the properties in the employee supertype are being inherited into the subtypes. In order to inherit the properties, here in between these both, if you see, we have placed a circle, and inside the circle I have placed an alphabet D, which is called as a subtype discriminator. It is called as a subtype discriminator. Discriminating means differentiating. So this discriminator is being to differentiate the employee's information, whether I want to take the employee's information into the pilot, whether I want to get the information of the pilot numbers, if I want to get the information of mechanics, or if I want to get the information of the accountants. This discriminator will help us to differentiate What the information? In which are we going to inherit the information from the parent class into the derived class? This is the diagram in which the first one is called as the supertype, followed by the three subtypes. In between the supertype and the subtype, the very important thing to be remembered is the subtype discriminator, which is being used to differentiate, from the parent class into the derived class. What are the being properties inherited? Whether the properties are being inherited into the pilot subtype or into the mechanic subtype or into the accountant subtype. This is how we represent the employee supertype and the subtype entities. Let us now in detail discuss about this subtype discriminator, followed by this subtype discriminator has it can be divided as a disjoint constraint or overlapping constraint or partial constraint or completeness constraint. Let us now discuss about how to what are these four and what is a subtype discriminator. As I already told, a subtype discriminator is being used to discriminate or differentiate the subtype entity that determines to which subtype the supertype entity is related to. The subtype discriminator is an attribute. It is an attribute in the subtype, in the entity subtype, that determines to which subtype the supertype occurrence is related to. And this subtype discriminator, as as I already told, it is represented in the form of a circle. In the form of a circle. Inside the circle, I have written the letter D, which is called as a discriminator. If inside the letter D, if I keep, it tells us to which employee type I should inherit the properties. That D discriminator tells us into which employee type I need to inherit the properties. In the place of D, if I keep the letter M, or if I substitute the letter M, it means that from the employee table, I have to inherit the mechanic properties and I have to set it into the employee subtype mechanic. If in that circle discriminator, if I write A, that means that from the employee supertype, I have to inherit the accountant features and I have to send it to the accountant subtype. And if I put the letter P inside the discriminator, then I have to inherit the employee properties of the pilot and inherit into the pilot subtype. This is how I represent a subtype discriminator. It is also an attribute. It is placed in between the supertype and subtype with a circle. Inside the circle, there will be a letter D, which is being replaced with either M or A or P, which means M for mechanic, wherein which the mechanic account numbers, employee details are being inherited into the mechanic subtype. If I write the letter A, the accountant subtype details are being included into the accountant. If I write the letter P, the pilot details of the employee are being carried into the pilot data type. This is how I represent the subtype discriminator. In this way of getting the properties from the base class into the derived class or from the parent entity into the child entity is called as, from the supertype into the subtype is called as inheritance. So what is inheritance? Inheritance is the property that enables the entity subtype to inherit the attributes and relationships into the supertype. To inherit the properties from the entity subtype into the supertype. So supertype entity consists of attributes that are common for all the subtypes. Supertype entity. What is a supertype entity here? Here the supertype entity is the employee. Employee has the common features for all the subtypes. What are the subtypes here? Pilot, mechanic and accountant. So common properties for pilot, mechanic, accountants include employee number, employee name, his date of join, etc. These all similar properties are placed in the supertype and these are being inherited into its own subtypes based on the discriminator. So the pilot, mechanic and accountants inherit the employee number, last name, first name, middle name, initial, date of join and so on from the entity supertype. This is about the inheritance and the subtype discriminator, followed by the next one as the types of constraints, which include the partial constraint, disjoint constraint, overlapping constraint, etc. Let us now discuss about all these definitions one by one. First one is disjoint constraint or the overlapping constraint. So what is a disjoint constraint? The entity supertype, it can be said to be disjoint or overlapping. An entity constraint, it can be called as, an entity supertype, it can be called as a disjoint or overlapping constraint when the subtypes are contain unique subsets of a supertype. Let me tell it again. An entity supertype can be disjoint or overlapping subtype when it contains a unique subset of a supertype entities. So what is this? So from the supertype, if I inherit the properties which are unique to the pilot, then it is called as disjoint. When I inherit the properties which are common for pilot and the mechanic, then it becomes an overlapping constraint. So about the overlapping constraint, let us consider it with one more example, which is in the next slide, which we will be discussing. Now let us discuss about the disjoint subtypes. So the disjoint subtypes are also called as non-overlapping subtypes. The one more name for disjoint subtypes is non-overlapping subtype that can be unique subset to its supertype, that has unique its own identification to the entity supertype. In the employee supertype, pilot is a subtype that can appear only in the pilot subtype entity. Is it or not? So pilot employee is a supertype from which I can inherit only the pilot subtype employee numbers, names, date of join, etc. and I can send them to the pilot supertype. And no other subtypes will get those pilot numbers. Either the pilot numbers are not being obtained into the accountant or into the mechanics. They are not being obtained into the other subtype. That is called as disjoint. This discriminator specifies that if the constraint is disjoint or overlapping. If I here write a P, which means that from the employee supertype, you please inherit the pilot numbers, names, etc. and please send it to the pilot subtype. That is called as disjoint constraint, and it is being represented with a letter D inside that. Inside the circle, if I put the letter D, it specifies that it is a disjoint constraint. Now coming about what is an overlapping constraint. So for the overlapping constraint, let us consider an example, employee. Employee, in which employee is considered as a supertype, employee is being considered as a supertype, and so again to discuss about the overlapping constraint, let us now consider an employee supertype. An employee supertype. In this example, I am going to consider the university environment. I am going to consider university in which one person, he is an employee in the university. So that person, he can be a student, also he can be an employee. As he is working in the university, he can do his job as well as if required, he can join in a course and he can also become a student. Here that means that one person, he is sharing or he is performing two tasks. What is that? One person, he is either he can be an employee, also he can be a student. An employee. One more example, an employee, he can be professor, also he can be an administrator. He can be a professor, also he can be an administrator. For example, if I consider a professor, he can also be a HOD. He can go to the class and take a lecture. Also being a HOD, he will be monitoring his colleagues of his own department if they are functioning or if they are doing their work properly or not. That is also called as an example of overlapping constraint. So here I consider again the employee, he can be a student and the employee can also be a person. A person, if we consider one person in the university, he can be a student, also he can be an employee. Just if I consider one person, he can be a professor, also he can be a HOD. Also he can be a HOD. As a professor, he will be taking the classes. As a HOD, what he will be doing? He will be monitoring his employees in his own department. These such type of constraints or such type of entities are called as overlapping constraints. Such type of entities are called as overlapping constraints. These overlapping subtypes, they are represented with the letter alphabet O inside the circle. Inside the discriminator circle, I have to write the overlapping constraint being represented with the circle O, which indicates that it is an overlapping constraint. Above that, I have told disjoint constraint, wherein which each one will be separate. Disjoint means they will not coincide or they will not, subtypes will not coincide with the other. One subtype will not inherit the other subtype properties, which is called as disjoint, which is represented with the alphabet D. And in the overlapping constraint, there can be overlap, the features can be overlapped, the properties can be overlapped, and it is represented with a circle, inside the circle with the alphabet O. This is the diagram which demonstrates how it is being represented. Here I am going to consider a person in which the primary key is the person ID, followed his by the person's first name and last name, and this is being considered as an overlapping constraint. See inside there, below that person entity, which is a super type, I have written a circle discriminator in which I have specified it as O, which means that an overlapping constraint, which means the person, he can be an employee, he can also be a student. So this is such type of constraints are called as overlapping constraints. Now if I consider employee again, this is also again an overlapping constraint. I am going to consider this employee as an overlapping constraint because a person, he can be an administrator as a HOD, also he can be a professor taking his own classes. An employee, he can be an administrator as a HOD, also he can be a person who is taking a classes. Also he can be a professor taking classes. So this is also considered as an overlapping constraint. Now if I consider the student again, here the student I am going to consider this as a disjoint constraint. I am going to consider the student as the disjoint constraint in which I am going to, how I am going to consider the student as disjoint means he will be doing either his graduation or his post graduation. At a time he cannot do both in the regular time of course. In the regular time of course, after completing his UG only, he can go for his PG. So in that way, I have considered the student as a disjoint constraint, in which here in the entity super type, that is the student, it is going to be disjoint to the graduation as well as to the post graduation. This is how I represent the disjoint constraints as well as the overlapping constraint. The first one is the person. It is an overlapping constraint to both the employee and the student. Again, the employee is an overlapping constraint for the administrator and the professor. Coming to the student, it is a disjoint constraint for the graduates and the postgraduates. This is how I represent the disjoint constraints and the overlapping constraint. Followed by the next one as the completeness constraint. What is a completeness constraint? A completeness constraint specifies that each supertype occurrence must be a member of at least one subtype. So compulsorily supertype should be a member of at least one subtype. Here in our diagram, an employee is a supertype. So in that employee, I should have the employee numbers which are being inherited either into the pilot or into the mechanic or into the accountant. It should definitely inherit, or the properties of the supertype should definitely be inherited into any one of these subtypes. Then it is called as a completeness constraint. And this completeness constraint, it is again divided into two categories which include partial or total. The completeness constraint is again divided into two types which include partial or total. So what is a partial constraint and what is a total constraint? So partial completeness constraint, how is it represented? With a circle and one line below that. Circle and a line below it. It is called as partial completeness constraint, which means that employee supertype occurrence must be a member of a subtype. Supertype, it should definitely be a member of a subtype. Total completeness constraint. The second one is the total completeness constraint, which is represented with a circle and two lines under it. Partial completeness constraint means circle with one line. Total completeness constraint means circle with two lines, which means that employee supertype occurrence must be a member of one subtype. Must be a member of at least one subtype. The single horizontal line, if we write one single horizontal line, it is called as partial completeness constraint. If we write two horizontal lines, that is a double horizontal line, indicates that it is a total completeness constraint. The disjoint or overlapping constraint can be applied to the completeness constraint. That is, the disjoint constraint can be complete or the overlapping constraint can also be complete. Again, the disjoint constraint can be partial or can be total, or the overlapping constraint can be partial or it can be total. This is how I represent the completeness constraint. The next one is, this is the diagrammatical representation of the partial constraint and the total constraint. Coming to the disjoint, partial disjoint constraint. It includes supertype is optional to subtype. Here there is no need to inherit the supertype properties into the subtype. Again, the subtype discriminator must be null. Here, because there is no guarantee that it should be inherited, so the subtype discriminator is being left null. Inside the circle, we will not write anything. The subtype discriminator sets are unique. The subtypes here, they should be unique. Coming to the total disjoint constraint. Coming to the total disjoint constraint, every supertype occurrence must be a member of at least one subtype. Every supertype, that is definitely it has to inherit the properties into the subtype. Subtype discriminator, it cannot be null. So here it should not be left null. So inside the circle I have to write the letter D. And the subtype sets, they should always here also be unique. Coming to the partial overlapping constraint, the partial overlapping constraint, the supertype is optional to subtype. The supertype here again becomes optional. That is, if required, we inherit into the subtype. If not, we will leave it in the partial overlapping constraint. So what happens here? Here also the subtype discriminator can be left because it is optional. It can be left empty. The discriminator circle symbol should be left if not required. If we do not inherit, if it is null, we leave the circle like that. So subtypes here, they are not unique. That is, it can be duplication. Coming to the total overlapping constraint, every supertype occurrence should be a member of a subtype. Compulsorily here the supertype must be inherited into the subtype, and because it has to inherit, subtype discriminator cannot be null. So here the subtype discriminator, inside the circle I have to write the letter O. I have to specify the letter O because it is total overlapping constraint. Inside the circle I have to write the letter O followed by 2 lines underneath it. So subtypes cannot be unique. Here there is no need that they should be unique. So this is the module summary ending, in which I have discussed about what is an entity supertype, what is an entity subtype, followed by what is the definition of a subtype discriminator, and followed by the various definitions which include disjoint constraints, overlapping constraint, completeness constraints. Thank you. I hope you all followed what I have told. Thank you very much.